Hello children, in the previous lecture I discussed regarding the drift velocity. You got expression for drift velocity in terms of electric field and relaxation time, and today I am going to discuss relation between drift velocity and electric current. Okay, so this is the relation between drift velocity and electric current. To derive the relation between drift velocity and electric current, let us consider a cylindrical conducting specimen of cross-sectional area A and length L. Okay, let us connect this cylindrical conductor to a source of EMF with potential difference V, and this end becomes positive, this end becomes negative. See, positive and negative ends are there. Due to this reason, an electric field is set up through the conductor from this to this side, means from left to right side. Is it clear? From left to right side, electric field is created here. Let n, small n, be the number density of free electrons, that is number of free electrons per unit volume of the conductor. Therefore, what will be the total electric charge available to constitute electric current? You see, small n is the number of free electrons per unit volume, and volume of this conductor, pi r square h, is volume of a cylinder, where pi r square is area A and h is length L. So this volume becomes AL. So total number of free electrons N into AL in the given conductor. Charge on a free electron is minus E. So net charge available for conduction is minus NALE. Got it? Total charge available for conduction is minus NALE. Now minus sign will represent only that electric current is opposite to the direction of flow of free electrons. Okay, so therefore electric current through the conductor is, you know, electric current is charge by time, so I is equal to Q by T. You take the magnitude of charge as NALE by T. You see, L by T is the velocity, speed, distance travelled per unit time, so it can be written as NEA, and L by T is drift velocity, VD. So the relation between an electric current and drift velocity is I is equal to NEA VD. This is the expression for electric current in terms of drift velocity. Have a close look on the board. Okay, after knowing about the relation between electric current and drift velocity, you can proceed by substituting the value of VD. So you know VD is equal to minus EE by M into tau. This is the value of VD. If we use only magnitude of VD here, then you can write it NEA. VD means EE by M into tau. Okay, and from here you can write NE square by M into tau AE. You can write it again NE square by M into tau A. You see, E is equal to dV by dr. E is equal to dV by dr. But if electric field is constant, then V is equal to E into D. Otherwise, V is equal to E dot dr. So let us come to this point, that it will be written as NE square by M into tau. You see, E is V by L. V by L, because you know E is equal to minus dV by dr. So this is V by L. This L can be written here and it will become A into V. Okay. Now let us proceed. Okay. So you got I is equal to N E squared tau by M A by L into V. And from here you can write V is equal to I. You see M by N E squared tau L by A. Can you write like this? Yes, you can write like this. Again you see, if you will compare it, you can see for a given conductor M is mass of a free electron, which is constant, always constant. N is number density of free electrons, means number of free electrons per unit volume, which is constant for a given material. So N is constant. E is charge on a free electron, it is also constant. Tau is relaxation time. So at a constant temperature, this tau will also remain constant. L, length of the conductor, which remains constant for a given conductor, and a area of cross section will also remain constant for the given conductor. So this term is constant for the given conductor, and this is called resistance, means this is equal to IR, means V is equal to IR, where R is equal to M by Ne squared tau L by A. And again see, M by Ne squared tau is constant for the given material of the conductor. L and A for the conductor can be changed. Means even if you have same material, suppose copper, L and A can be different for different conductors, different size of conductors made by copper. But M, N, E and tau will remain constant at constant temperature. So this term is also constant. Okay. So it can also be written as rho L by A, means R is equal to rho L by A, where rho is equal to M by Ne square tau. M by Ne square tau is a constant, for the material of the conductor, at constant temperature, You see, if the temperature will vary, then this relaxation time will change. Means if temperature is more, relaxation time becomes less. So relaxation time depends upon temperature. Hence at constant temperature this is constant, and it is called resistivity of the material. So what can you conclude from here? You can conclude that resistivity of a material remains constant for a given conductor, given material, but it will change. Resistivity of a material remains constant, but it will change if temperature will change. Okay, resistivity remains constant at constant temperature, and R is equal to rho L by A is a constant for the given conductor, and it is called resistance of the conductor, called its resistance, means R is the resistance of the conductor. Got it? And from here you can write V is proportional to I, or I is proportional to V, and I is proportional to V. This is called Ohm's law. You learnt about this Ohm's law in class 10 also. Means on the basis of this you can write the statement of Ohm's law, that is electric current through a conductor is directly proportional to the potential difference across its ends. This is Ohm's law. But one condition is here, that Ohm's law is valid only when temperature is constant. If temperature will change, then Ohm's law will not be followed. Okay, so this is Ohm's law. I will discuss Ohm's law in detail in the next lecture. After knowing about these, you can understand that resistivity rho is equal to m by n squared tau, and resistance R is equal to rho L by A. Means resistance is directly proportional to length of the conductor, and it is inversely proportional to area of cross section of the conductor. So this is the explanation for a drift velocity and electric current in connection with each other, and in connection with the potential difference and electric field also. Is it clear? So in the next lecture I will discuss about the qualitative idea of resistance, qualitative idea of resistivity. I will also discuss Ohm's law in detail, and then I will discuss Ohm's law in microscopic form, which will be the new idea about Ohm's law in comparison to the ideas you had in class 10. Thank you.